Today we're looking at lesson 5.5, which is inequalities involving absolute values. So we're going to be solving absolute value inequalities. Just like any absolute value problem, you're going to have a range of values as your answer. So in this case, you're going to have a range of 2 values. So when you're solving an absolute value inequality, you're going to have to set the inequality up as a compound inequality in the beginning. There's 2 choices for compound inequalities, as we learned in lesson 5.4, which would be and inequalities and or inequalities. And there's a trick to remembering which type the absolute value is supposed to be set up as, and it depends on what type of symbol it has. So if this one in particular has a less than symbol, I remember that how to set it up by remembering the phrase less than. So if it's a less than symbol, it's going to be an and inequality. So what I'm going to do when I set this up is I'm going to separate it out into 2 problems and writing it as an inequality that's an and. So I put the same inequality that I started with, okay, and that is here. But then on the other side, I had to have the other range of values, which would need to be flipping the symbol, so now it's greater than or equal to, and then changing the sign. So it's greater than or equal to -2 instead of less than or equal to 2. But I'm going to solve this whole thing. So to solve, I would need to add 8 to both sides, as we did yesterday, and then rewrite my inequality as an and inequality. And if I were to graph it, the same would apply to when I'm graphing a compound inequality. I'd need to have both values on my graph, closed circles because of the symbols, and it's an and, so I know that the 2 values are going to be pointing towards each other, and that would be my answer, this whole thing. Here we also have a less than symbol, so again this is going to be an and problem, so I'm going to set it up before I solve as an and. I copy it just how it is, and then on the other side I put the opposite symbol and the opposite sign of the number, and then I need to solve. Oops. This one I didn't catch. This one is -3. When you have an absolute value and you have it equal to or less than or greater than anything that's a negative number, you automatically say no solution. So this one is actually a special one. And I know it's no solution because it's absolute value and it has a negative with the number after the inequality symbol. Here we have a different one. This one is greater than. So to remember how to set up a greater than problem, it's going to be using the phrase greater. So that's greater, which would mean an or problem. So I'm going to write this just how it is. And notice when I rewrite these, I rewrite them without the symbols, the absolute value symbols. And I'm also doing the same thing that I did with and inequalities. I have one with the same exact setup as the starting point, and then one that flips the symbol and has a negative number. But we're still solving them separately. So k would be greater than 3, or k would be less than negative 4. So we would have these two graphed on our number line. And I'd have an open circle at both negative 4 and 3. And k is greater than 3, so it would go this way, and k is less than negative 4, so it would go the opposite, which is how most OR graphs look like. And here's one more with a greater than symbol. So again, greater tells us we set it up as an OR inequality with an OR in between. I rewrite what I'm given without the absolute value symbols, and then I flip the symbol and do the opposite. Oh, again, I caught myself. I didn't catch myself in time. Now, to explain this, the first example where we had less than or equal to, or a less than symbol, and then a negative number following that, we put no solution. But when you have a greater than symbol or a greater than or equal to symbol, when you have absolute value and you have a negative number after the symbol, this, instead of no solution, is going to be all real numbers. So it's going to depend on what the symbol is with absolute value inequalities to be determining whether it's going to be all real numbers or no solution. But this only applies when you have a negative number after the inequality symbol. And then we have one more word problem here. This is explaining the melting point of ice. So it says the melting point of ice is 0. During a chemistry experiment, Jill observed ice melting within 2 degrees of this measure. So we need to write a range of values for this. So whenever you're setting up absolute value equations, we talked about this a while ago, you would have x minus the given value in absolute value symbols, and then you'd have equals the margin of error is what they called it. And instead of this being equal to, we just need to change it to match the symbol that the problem has. So if we look at this, it says Jill observed ice melting within 2 degrees of this measurement. So if it's within 2 degrees, that means it needs to be less than or equal to 2. So when we set this up, this particular problem is going to have a less than or equal to symbol, which not all problems are going to have that, but in this case, within, that's what it means. So we just need to fill in excuse me, the given value and the margin of error. So the given value is 0, because it says the melting point of ice is 0, so that's going to be x minus 0. And then less than or equal to stays there, and then it needs to be within 2, so we're going to put 2 on the other side. Now this is a less than symbol, so we need to split this up into an and inequality. So it's going to look like this, and then on the other side we flip the symbol and we add the opposite sign to the 2. And we're going to solve this. So really what happens is that 0, you can't add 0 to anything, it doesn't do anything to it, so it ends up being the range of values are x is less than or equal to 2 and x is greater than or equal to negative 2. And that would be our answer. And that concludes lesson 5.5.